No problem.
Okay. So we're going to continue from where we left off on Wednesday, which is complete the second contract that will allow us sort of like see how cross-contract interaction works. So I'm going to go ahead and share my screen and kick off from there.
Mubarak, are you there? I don't think I can see your screen or hear you. Okay.
Yes, I'm here. So yeah. So on Wednesday, right, we were able to sort of like build this contract, right? It has three functions, right? The name of the token, the balance of that token, and then the transfer, right? So I'm going to go ahead and sort of like start working on the second contract and continue from there. Yes. Now, the second contract is expected to do the following. Right? Based on the name, right? Expected to do the following. Yes, expected to do deposit, right? And withdraw from it, right? So you can basically like sort of deposit a particular token and withdraw a particular token. And this is where you will have to interact with the second contract. Okay, let me zoom in. If it is clear now, can you guys hear me? Yes, so yeah. Thank you, Hilary. Hilary, for that question. So the agenda for today is basically rounding up where what we started working on Wednesday, right? And sort of answering some of your questions that you have so far from what we've done on Monday, Wednesday, and today, right? And then we'll talk about the week assignment. So yeah, these are like the outline we have for today. So yeah, let's continue. Now, the first thing we want to do is define our interface, right? And going to do a bit of, we all know what this is, it, right? This is what we define if you're trying to sort of like define your interface, right? And what we have here is pop trade I vote. Yeah. And yeah. And who can, okay. And this is where we sort of like define our T state, right? And we said we want to have a deposit, right? Because it is a deposit, right? It's going to change state, right? So we need to reference the state. Yeah. So, and referencing the states, we also need to take in the token address we're trying to deposit and the amount. So yes, we have our way, right, which is the T contract, and we also need to have the token. Token, we will have to have contract address. This is going to shout, but 256. Yeah. Then the next thing we want to do is draw, right? And same thing here. It's going to change states. So instead of taking, we're going to take a reference of the state. And it's looking we're trying to pull out, withdraw, and the contract states. Yeah, sorry, the contract address of the token we're trying to, and the amount. Yeah, 256. And then the last thing we want to know the balance of any token that we have. Yeah, it's very important that we sort of like have that. So if I pass in a particular token that I have, we should be able to know the balance of that token. So I'm going to do this. Yeah. In this case, I'm going to take a snapshot. Yeah. I'm going to take a snapshot of the states. Yeah. Because we are not reading, we are not sort of like changing the state. We are basically reading a particular value from the state. So serve this with the T, and then the token amount, token we're trying to know the amount, right? And it's going to return the U256, and we're trying to get an amount. So yeah, I'm going to import some utility that the Starknet core give us, which is this. By the time we sort of like start working on the implementing this particular interface, this will shout at us saying that we need to import this before we can use it. So yeah, I'm going to come up here. Yeah, I'm going to come up here and say use core dot Starknet dot contract address. So yeah, does anybody has any question from the interface I just worked on now?
Yes, please. On line 3, what
Okay.
is why did you put the use core? Because all the former contracts we've been writing, there's nothing like that.
Yes. So like I said, right, there are some utilities that comes from Starknet core, that you don't necessarily have to do. You can call them and use them. Some of these utilities are basically sort of like tools that allow you to sort of like do things that you don't have to write from scratch. For example, the contract address, right? Now, the contract address, it's a type, right? So every time you're trying to define a particular variable that accepts its contract address, you can basically sort of like pass in this particular call as a type, and it's going to mean it for you. Apart from this contract address, we have other like utility that comes from Starknet code that we use. For example, the map. I'm very sure when we from our classroom contract, we've used this storage map. If you're with us on Wednesday, we use this Starknet tools, right? This particular tools from Starknet core within our contract. So yeah, I hope that answers your question. Okay, who is raising his hands? Yeah, you can ask your question. You can ask your question if you're raising your hand.
Okay. Good evening, sir. Can you hear me?
Yes, I can hear you.
Okay. I have a question about line 7 and 8.
Go ahead.
So this we are defining a contract, right? And we are kind of supposed to deposit or withdraw from that contract, right? Hello.
Yeah, go on.
Did you get what my last questions?
So deposit, right? We're trying to deposit a particular token, and for us to deposit that token, we need to have the address of that token, the contract address of token we're trying to deposit, and that's why we are accepting this token and then the address. Maybe the name it might be wrong, right? Maybe I should say token address. That might be a bit clearer. Yeah.
Okay, the smart contract receives different tokens.
Yes.
Because I was thinking it will only be receiving, let me say, Starknet's native token or something like
No,
that.
no. So depending on what we define here, when we deploy this, depending on what we define here, that's what it's going to do. So if you define a token that says, give it a name that says, okay, what name should I call it? That says TX, right? And then you want to deposit that TX of that token, you're going to do that, right? So that's where we'll see the contract interaction between them. For now, by the time we implement the functions that are here, we will see why we are doing this. The whole essence of doing these two contracts is to show that how one contract can actually interact with another contract via what we call dispatchers.
All right. Thank you.
Okay, so let's go ahead. So I'm going to go ahead and define what we call like the contract itself, right? Sort of like okay. Okay. And just like I said, right, they are mod, right? So what name should we give it? What name should we give it? Okay. What name should we give it? Okay. What name should we give this? Okay, hold on a second. Yeah, we can give it vote. It's fine. Can give it vote. It's fine. So what do we want to do? The first thing we want to do is, what do we want to do here? We want to import, we want to import certain we want to import the interface, right? And we do that by saying super I vote. Yeah, going up and pulling I vote, because I vote is not within this scope. So we need to use the super to call it. Now, before I proceed, right, there's something called dispatchers. Now, I'm going to try and explain dispatchers here. So dispatchers are sort of like your, call it like handshake that allow you to connect one contract to another and give you access to that particular contract interface functions. So I'm going to sort of like import the interface of this vote contract, right? And the way I do it is I come here and say here we'll have to use the use. Yeah, then we'll say use a contract. I'm going to bring this contract here so that I can have it accessed globally. Mode. What do we call it? We called it I vote. Yeah. ARC20. That is the name. Now, when we define it this way, when we come here, it's going to give us access to ARC20. And then I'm going to say what we'll call this. What we'll call this. Now, I know you guys will be shouting at like, why are we having this? Right? Why are we having this? Like, why are we having this here? So live.cairo is like your on the sort of like on the root 3 of our project. Live.cairo is where we sort of like put out all our functions so that other contract can actually access those particular contract. And this is where we had to put it here. Now, then the second one, which is the IERC 2020 dispatchers. So, like I said, right, dispatchers are sort of like your, how will I call it? Your sort of like, look at them as your gateway to accessing other contract functions. And if you want to access a particular contract function, this is the convention. The interface name and then you add dispatchers to it. So for example, if we are in another contract and we want to access the interface of this vote contract, all we have to do is come here, hub mode, yeah, then we do vote. And when we come here, we can access the interface of that vote contract by basically doing use cross contract. So cross contract is the name of the contract, right? And you can always pick it from here, from the Scarb.toml file, and say this, right? Vote, and then you basically pick up this, yeah, and then you add dispatches. This now in this our function, we can basically pick up the functions from here, the interface functions of this particular contract. But yeah, here, why do we need this? So we need this because this is where we define our contract. Okay, yeah, it's shouting because we don't have a storage structure. So every contract will have must have a storage, even if there's nothing you would do with that storage, but you have it and make it an empty. So yeah, we're going to have storage. Yep. So even if there's nothing that you put in that you put on that storage, you have to define it. But obviously, in this case, we are going to define we're going to define what we call balances, and balances is going to have what we define as, we're going to have like a map that has a tuple. Remember the tuple you did from last week, right? So the tuple is basically going to be like contract address. Okay, contract address, where is it? So we needed to import the contract address also here. So I'm going to use core Starknet track address map. And remember that we have storage. Storage comes with certain access. The storage give us access to this store libraries. So we're going to import. It's still within the Starknet core. Yeah. Now this is going to, the map is going to contain a tuple of the user, the caller contract address, and the token contract address, right? Map to a U256, which is like the balance. So, like I said, I always like to do it, like push it this way, right? Where you sort of like tell me this is what we are trying to do, right? User address, token address. Okay. And amount. Yeah. So this is it, right? Yes, I didn't send it because we are still working on it, right? So by the time we are done working on it, I'm going to send both this vote contract and the ERC20 contract. So yeah, let's continue. Okay, now next thing we want to do is we want to implement our functions. We want to sort of like do what we call implement our function. First off, we want to implement vote, right? The I interfaces. So what do we want to do here? First off, we want to make it an external, right? So that other contract can access them. And then we do the imp, yeah, vote imp of I vote. So now we have it. We don't need to put that super, right? But I vote is going to accept contract state, right? Just like we did in a previous contract. So first up, we want to do deposit. Now, yes, okay, okay. Going to change this, right? Now, first off, what will it do is going to deposit, and the first thing we want to do, we want to get the caller address and the token dispatcher. And the moment we have that, the next thing we want to do is we want to call the transfer function of our ERC20 contract. Yeah. Let's caller. So caller, for us to get the caller, there's a particular utility function coming from Starknet core called get caller address. It's a very important utility function that if you want to know the caller of your particular of your function, you can basically just call it and it will tell you the caller of the person calling this particular function. Now we want to do what we call token dispatcher. Yes, so this is very important that we understand what I'm going to do here. Now, token dispatcher, what basically does it allow you to sort of like define the contract you're trying to access and so that it will give you access to those interface functions. Okay, somebody trying to speak? Somebody trying to raise his hand for a question? Okay, nobody says in hand. Okay, let me continue. Okay. Now, it's very important that you understand what I'm going to do here. So now, iDispatcher, this dispatcher function needs to sort of like pass it the address. It always need contract address. And this is where we're passing the token address we're trying to access. Contract, you see, contract address. Now, we are going to pass in the contract address of the token we're trying to access. So ERC20 token dispatcher it's sort of like when we deploy the ERC20 token contract, we are going to have an address, and that address is what we will pass in whenever we're calling this deposit function, and it's going to pass it here. And the moment it passes it here is going to give us access to the functions. Now, it's going to give us access to the functions of these contracts. Now, interaction. Yeah. Now, I'm going to process transfer. I'm going to say token dot. So yeah, this is a very important scenario here. By default, right, it should show me the list of all the functions coming from here, coming from this interface, name, balance, transfer, but it's not showing. And that's because, oh, okay, it's coming up. Yes, so, and that's because it's still not recognizing this particular interface. It's still not seeing this particular interface. Now, I'm going to come back to that and fix that. But remember our function here? Well, what does it collect? It collects the amount and recipient address. So, and what do we want to do here? We want to pass in the amount and the recipient address. Which one comes first? So it's important that we know the order, right? The order of how the argument are created. It is well, it's the amount is the first argument and the recipient. You don't need to pass in this state. This is something that is passed to you by default. You don't need to pass the first one, the one that references state. Just need to pass in the first one and the second one. And in this case here, we are passing the amount and the recipient. Amount and in this case color. Now let me go back up and try to fix this error that we are having. Okay, give me some seconds. Another way we could do this is like bring all the interfaces here. This interface here. We'll see what will happen if we do that. And what that means is that we will not have to do it here. All we have to do is do super, and yep, we have it here. This is another way to do it, right? You sort of like define the interface of what you're trying to call, and from there you pick it. Yes, and again, we made a mistake here. We're supposed to call this. I made a mistake here. I'm supposed to call this token dispatcher dot transfer. Okay, so it's still shouting that it doesn't recognize this interface that we have here. So going to go back. Oh, so let's look at it again. How do we bring in these interface functions in here? So what I could do is look at it again. It's a public thread, right? So I could say public I'm going to create a folder and call it ARC20 and move all the implementation that we have here in here. Call it ARC20.Cairo. Okay, somebody have a question? Okay, I'm coming back. I'm coming to now. What we do is pop mode and see ARC20. Yeah, and then from here we can basically see ARC20 mode ARC20, and we can come back here and come back and see ARC20. So what is it shouting? It's shouting that it can't find this. Oh, okay. Just that. I guess that was the error we're having. RC. So what I'm basically doing, I'm trying to fix the parts between them. ARC20. You should see it. You should be able to see it right now. Awesome. So you could see that it's able to see the two. Awesome. So when we come here and sort of see cross contract, come here. I don't need this. We can basically say use cross contract. It's going to point to this. Yeah. And I will do, it's going to give us access to the interface of this. And you can say this. And yeah. So I'm wondering why it's not saying it. Maybe we don't need to do it this way, because we're only accessing that interface, so we can make it this way. Okay, hold on a second. Anybody having a question? Oh yeah, yeah. Exactly. Thank you. So I'm wondering, do we need to go back? Yeah, we need to. Exactly. So we are going up, right? From here, it's coming here. So I'm wondering why we are having a bunch of errors with this. Interesting. Oh, okay. So again, remember what we did here with the votes? Instead of had to import this contracted above for us to use the contract address in this, and this is exactly what is happening here. We used it, but we didn't import it, and that's why the compiler is shouting at us. Exactly. Then yes. So again, we are not referencing the main contract state. We're referencing the mock. Yeah, so this should go away. Oh, it didn't. Okay. Balances. So there's also some errors with the spelling. Awesome. Okay. So yeah, we have that. And then here we fix that. So I'm going to refactor this also the same way that we did here by creating what we call vote, and then creating what we call vote.cairo. I'm moving everything that we've done here in here. And here we delete everything and made it expose what we have here. Vote. And then I will come here and yep. So back to this place, right? So why are we having issues with the transfer? Exactly. So you shouldn't be having this issue. So it's shouting at us that method transfer on. You didn't mean to import, and I mean we've imported it. So why? Oh, hold on a second. There was something I'm doing that is wrong. Okay. There is definitely a reason why we can't access this here, but we're going to come back to this particular error, just like we did when we were trying to fix these other ones. No, we don't need it here. We don't need it. I'm going to come back to this error, why this is happening. But after that, what we needed to do is update our internal balance. And we see current balance. We need to do self dot balances. Yeah, is it balances? Oh, okay. Yeah, self dot balance. So balance dot read, and you are basically passing in the token address and the color so that you get this value. Remember the mapping, the user address, right? So when you pass in this tuple value, it's going to return you the amount. And that's exactly what we are going to do here. We're going to do a tuple color. Yeah, is it the first thing color? Yes, color and the token address. And then we have what to do, token address. And what is return is it returns us the the balance. Now, we need to do the next thing. Since we deposited it, we need to do the next, which is update our balance. So the same thing we did here. Okay, same thing we did here. So what we'll do is we'll do self.balance dot write, and here we are going to do a tuple of color, token address, and current balance plus the amount you deposited. But again, we need to find a way to assert to make sure that that transfer was successful. Yes, because if it is not successful, we should not update the balance of that user. So yeah, that's exactly what I'm going to do here. Now, yeah, then remember what we talked about on Wednesday, assert, where you're able to assert if something has actually happened. If it did not, you want to stop the function execution and return. So assert success okay, what should we be? Okay, yeah. Transfer fail. Yeah. Uh, transfer fail. Okay. Okay. So we've done with this function, right? But we're going to go over this function to see why this is not returning what we expected it to do. And I'm suspecting it has to do because the function is not public. It shouldn't be. Shouldn't be the reason why. Shouldn't be the reason why we. I can see it here. I can see the name here. I see balance of all of them here. But compiler is shouting method not. Okay. 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 Yes. So this IARC20 dispatcher is what allow us to sort of like connect to the other contract we are trying to, the contract that implemented this IARC20 interface, right? While this IARC20 dispatcher trade give us access to the trade functions. If you remember when I removed, when this one was not there, he was shouting at us that, look, you've not, look at what he's saying. Method transfer not found on the type. Did you import the correct trade and implement? Exactly. So apart from is we need to import this. It's the same thing, but then you add the trade to it, which give you access to the trade function. So every time you want to get access to a particular contract functions, right, you have to first of all connect to the contract, and you do that by doing this. And after you've done that, you then need to, your iDispatcher connects your contract address, and then you pass it the token address. And we'll get this token address when we deploy our ERC20 contracts. Then you then import the dispatcher thread, which give you access to the trade functions. This ERC20 dispatcher allow you to connect to the contract using its contract address, while the dispatcher thread give you access to those thread functions. And that's why this thing stop shouting. Now I'm going to quickly go ahead and like work on the second function so that we can see how we can deploy, see how the whole thing works, right? And then go ahead and explain what we are going to do on the assignment. But does anybody has any question with regards to how I was able to access the ERC20 contract transfer function from the vote contract? There's no question. I expect question from here. Because I know this is another like new concept that we didn't talk about last from our previous classes. Okay. In the absence of any question, I'm going to, oh, okay. So withdraw is almost the same thing. We don't need this. We don't need it. Withdraw is almost the same thing, right? You're trying to withdraw certain amount from the token. So I'm going to quickly rush to write this function. Then I'll explain what exactly the function is doing. Okay. We'll first of all get the color of get the color of the contract. Yeah. Our awesome Starknet core tool that allows to get, yes. Then we do an assertion. We need to get the current balance of the color. So that he can only withdraw what he has, right? The amount of token he has. And to do that, we need to balance dot read, yeah. Yep. Because it's a tuple of the caller address and the token, and then map to the amount. A tuple map to an amount. A tuple of the caller and token map to an amount. And this is what we have here. The tuple of the caller contract address and the token address. So we have what caller and token address. This will return us the, and we want to assert current balance that the current balance greater than or equals to amount we are trying to withdraw. Yes. And if it false, you throw an error, but if it is true, that means we can actually withdraw the amount. Then connect to ERC20 token contract. Let ERC20 dispatcher. Yep, exactly the same thing we did here. We basically call it yep. So we want to do sort of like do transfer, yeah, and then reduce the balance. So it's almost the same thing, except this time around we're reducing the balance. So we're going to do this, right? Let's do this, right? So we say in dispatcher. So I'm changing them so that for you to know that you can actually, it's just like a variable that points to another contract. So you can name it whatever name you want. That's why I changed the name here. And once that is done, we want to do is reduce the balance, deduct the current balance. Yeah, current balance minus amount. So yeah, this is the withdraw function. And the next thing I want to do, so the withdraw function basically, I mean for the name, right? You have a token address and an amount you're trying to withdraw from that token address. And what I did here, I got the caller. So I want to know who is the caller of this function, right? And then I use that caller and the token to get his balance, which is what we did here, right? And then I do an assertion. The assertion is basically checking current balance greater than or equals to amount. If it is true, yes, we continue. If it is false, this assertion will throw back an error and the function will stop executing. Yes. And then we proceed, right, to connect to our ERC20 contract via the dispatcher. Yes. And this is how we do. This is the capstone point of cross-contract interaction. Right. You see dispatchers a lot when you're writing tests for contract, right? And also when you're consuming other people's components or other people's contract into your own contract. That's something that you do a lot. So it's important that you understand what this contract dispatcher does here. And yeah, after that, we then call this transfer function, passing the amount and the caller, and we assert that if actually it's a fail, right, you return an error, it has failed. But if it is true, we just proceed to do the balance from that user. So yeah, does anybody has any question from the withdrawal function I just implemented now? Okay. So are you guys telling me that like you understand from the point of the dispatchers and how the traits give us access to these functions? Interesting. Okay. Okay. Hold on a second. Now, I'm going to go ahead and sort of like implement the balance function. Yeah, and just like I said, the balance function, it's basically reading from the state. Okay. It's going to, oh no, going to say self dot, let's get color. Let's color, right? We want to know the color of the function. Once we do that, okay, where are we having this? Then self dot balance dot read. And we'll pass in a tuple of the color and the token address. We'll come here and remove this. Yeah. So we just finished like implementing all of the interfaces here and showed us what's possible with contract interactions. So I'm going to sort of like go ahead and sort of like build this and see if we have any error that comes up while we're okay. FNT. Okay, just to do some formatting. Now we want to do this Scarb build. Okay. Okay. So we've successfully built this contract, and yeah, so this is all about sort of like cross-contract interactions, right? So if there's any question from here, you can raise your hand and ask. If there's not, then I'm going to go ahead and sort of like walk us through the assignment contract we're going to work on for this week. Okay. Is it okay? Eric. Yeah, Eric, you can unmute and ask a question.
All right. Good evening, Barak.
Yeah.
My question is,
Yes.
I couldn't understand the entire reason why we had to like put them. I think the whole reason why we had to put them into folders as the ERC20 contract, the Vault contract, and
Yes.
what then becomes of the lib.cairo file after we have them in their own separate folders.
Oh, you want to know why we had to put them in folders, right?
Yes, and then if they are, since they are in folders now, then the lib.cairo, what's its purpose again at this point?
Yes, so the lib.cairo is sort of like your, take it as sort of your entry point to your, not like entry point, right? But like your, take it as your access gate to the like the file paths across the projects. So if I come back here, right, let's look at it closely. You look at it in lib.cairo. What does it has? It has ERC20 and it has roots, right? And if you look at it here, we have the ERC20, which is basically exposing it, and also the roots, which is basically exposing it out, so that whatever, anywhere in our contract, whatever contract that is trying to access any of this particular contract is going to follow through the lib.cairo. Lib.cairo basically tell every other contract within that particular folder that yes, this is, you can access it from here. And if you look at what we did here, okay, no, the root. If you look at what we did here, can you see? We went to the cross contract, like our project, like our project name, cross interaction, cross interact. Then what did we do? We first off reach here. The first thing we're going to reach here. And that's why we have this. It's going to reach here. From this here, it's going to look at here. And we have this here already. Yeah? And that's why it's here now. And from here, we'll come here. Here is, this is basically exposing what we have here. And if you look at it clearly, the moment we move from here, it goes to lib.cairo. Lib.cairo points it to this place, and from here we get access to this. So this is sort of like, not like like written in stone way of arranging your files, right? But if you sort of understand how file system works, you can sort of like rearrange your files and folder structures to suit the way you sort of like understand. But this is like how I sort of like arrange my file structures to have multiple contracts in the same project. I don't know if that answers your question.
Yes, it does. I understand how file systems work, and that was why I was looking at this, and it was just looking a bit too much. I was just thinking, I mean, I was just looking a bit too much. So I wanted to just get clarification. No problem.
Okay. Who is raising his hands up next? But Eric, you sort of like understand like how the cross-contract interaction works, right?
Yes, I do. Yeah.
Awesome.
Please, I don't understand the contract interaction. Please, can you just go over it a minute?
Okay. Now, cross-contract interaction basically means one contract is trying to access functions of another contract. And in this case, we have two contracts. We have the ERC20 contract and the vote contract. Now, the vote contract is going to access ERC20 contract functions, which is basically the transfer function. Now, for you to get access to that contract, you need to have the contract address of that contract. And when you do that, what you have is an address. And in your contract, in this vote contract, you're trying to access the ERC20 contract, right? You need to get the dispatchers of that other contract, right? And since you have the contract address of that other contract you're trying to access in here, you need to come and define the dispatcher. The dispatcher basically allows you to connect to the other contract. And in this case, ERC20 contract, ERC20 contract has a dispatcher, and that dispatcher is the interface name plus the dispatcher keyword. That's what we have here. And that's why we sort of like import it from here. And when you do that, you then pass in this, the contract address, and then the actual contract address, like the contract address key, and then the contract address value. So this is like a sort of like the standard way to sort of like connect a particular contract via the dispatchers. You looked at that contract interface dispatcher, and what I mean by dispatcher is basically the interface name plus the dispatcher keyword. And once you import it into your contract, then you now bring it here and have a query brace, contract name as the key, the contract address that you deploy, you're trying to access, you pass in there. And I mean, we know where we can get contract address, right, from the Etherscan or Vilga. Like those are like two places we can go and get contract addresses of whatever contract we're trying to access. So yeah, these are like the cornerstone way of connecting one contract to another. And in order for you to get access to those contract functions, you need to import the trait of that interface. And it's being done this way. The interface name plus the dispatcher trait will give you access to the functions of that contract that you just connected with via the dispatcher. I hope that's clear now.
Oh, yes, sir. But please go to line 15. Line 15.
Line 15. Okay. Yeah. Here.
Yeah, you put use cross interact.
Yes.
ERC20, and this looks so ambiguous. Please, can you explain it a bit so I can understand?
So I'm following the file path tree, right? Just like I said, right, from what Eric has asked, right? If you understand how file structure works, you can actually structure this into a better way. But because I'm using certain file structure flow, right? When I use cross interact, at this point of the project name itself, the first access point is going to get is the lib.cairo. It will not get any of this. It's going to get lib.cairo. And inside our lib.cairo, it has ERC20 module. It's public. That's why we have it here. So, and that ERC20 module is pointing to a particular file called ERC20. Yeah, which exposes this our folder that contains our contract, which gives us access to the interface thread. Okay, well, does that answer your question?
Yes.
Okay. Wisdom, you can go on.
Thank you. Good evening, sir. Can you hear me?
Yes, I can hear you.
Same in that line 15. We have ERC20 and then another ERC20. Is it possible to
change the names, like give it even if it's another annotation, so that it can be different from the other, because it seems confusing, both of them bearing the same name.
Yes, it's possible. It's possible. We can do name it so like mode. Yeah. And when you name it mode, you see that this will shout. Can you see? Because this lib is trying to is looking for a folder that has a file that has this name. So if I come here and do mode, everything should be sorted out now. Now, again, now this is shouting that it doesn't, you can't find. Oh, okay. And I totally get what's happening here. So here, right? So yeah, what's happening here is this is trying to look for a folder. It's trying to look for a folder that has this name, but we don't. But we don't have it. What we have is ER72. That's why this is showing an error. So in essence, right, this is a file. This is like a file that is trying to look for a folder that has the same name as this. This is a file, right? But here it's trying to look for a folder that has this name. And if you make it this way, it's going to show because it can't find it. Because it can't find it. Look at what the error is saying. Module file not found. Expected, can you see? User MacBook Pro, document classes, cross-contract interaction, ERC20. Can you see? Then, sorry, cross-contract interaction, ERC, then ERC20 slash DRC. Can you see? So this name and this name has to, the folder name and this name has to be the same. Yeah, in coming classes, you talk about this, a lot of this structure, how to structure like different contract in the same project. You talk about it. You talk about base. Talk about interface, like arranging your contract into like an interface folder and exposing them out, right? Whereby you have like one folder that has different interfaces in them, and then you expose them. As against what we're doing here, where we're having all of them, like each contract having its own interface folder in it. So yeah, I hope that answers your question. That's exactly what we're doing. We're importing it here. That's exactly what we're doing. That's exactly what we're doing. We're importing it here. By following the file path. Okay, so in the absence of any question, I'm going to sort of like explain to us the test, the week assessment, what we're going to work on during this week for our assessment. then we call it a wrap.
Hello, sir. Hello, sir.
Yes, I'm here.
Okay. Yeah, you said we'll do deployment too on testnet. So are you not going to do it today?
Yes, so the deployment on testnet, I will need to sort of like deployment account and a whole lot of process that goes around there, right? So we still have, this is week 3, right? We still have 4, yeah, 4 more classes, right? And in all of those classes, you do something around contract deployment. So yeah, I won't be able to do it on this call, but in okay, hold on a sec. So I mean, I can be able to deploy it here, right? But you guys might not fully understand what I'm doing because you don't have the deployment account set up and all of those things. Okay. Okay. I'm going to share my screen. So now this is what we like you're going to do like a bookstore contract, right? And it's open-ended, right? The sort of like it's open-ended. We all know that sort of like what a bookstore does, right? Has like a list of books that you can keep there. You can get a book from there. You can like, I mean, you can make learn through. Right, the bookstore should have an interface that has some functions, right? Use some of the Starknet core get get uh get caller address, right? Basically sort of like the assignment, right? So it's open-ended, right? When you're sort of like done with it, you submit it with link to the repo, right? And I'll sort of review it and give comment on each of the contract that you guys write. So yeah, this is like it for this week. And yeah, if there's any questions so far from what we've done from Monday to Wednesday to today, the floor is open to ask that question now. Yeah, Eric, you can go on.
All right. So far so good. Everything has been going fine. My issue now is with building. For the past, I think, did I say since Monday, I've been trying to build, the projects we're working on, and mine hasn't worked out. I'm getting this error 0277. I don't know if it's from the SN Forge. It looks like an SN Forge error because it's not really
Is it?
coming from my code per se. Let me just copy the error message and paste on the.
Yeah.
Yeah.
Hmm. Hmm. Hmm.
So I don't know if it's something from the version of SN Forge I'm using, but I'm using the latest 0.30. I don't know whether it's from there or how I installed it.
SM4 0.3. Is that the version you're using?
Yes, yes.
Can you hear me?
I can hear you. Can you hear me?
Okay, I can hear you now.
Yeah.
What version of Scarb do you have?
Version 2.8.1.
Yeah, so you shouldn't have this. Shouldn't have this challenge. So what I would suggest is downgrade your Scarb version to
Okay.
2.8.2 and also downgrade your SM Forge version to 2.7 0.27.
0.27. SN Forge, I should downgrade to 2.8, right?
Scarb
Sorry,
2.8,
yes, 2.8. And SN
then
Forge to 0.27.
0.27. If
All right.
yeah, if that
Okay.
doesn't go, so what you can do is push the code to GitHub and I'll have a look at it.
All right. No problem.
Yeah. Does anybody has any question? Are we all clear on the assignment? What we need to do on the assignment? And I get a hand like an email, like yeah. Yeah, go on.
Yeah, about the assignments, please. I did not hear you well. Like I had network issues, so I left the
Oh,
call.
okay.
Please, can you reiterate what you said about the assignment, please?
Yeah, so the assignment is build a bookstore contract. We all know what a bookstore does, right? You can buy a book, right? Add more book to the store, rent a book. I mean, implement a bookstore contract that does like what a bookstore does, right? So it's an open-ended, right? Think of what will a bookstore does, right? And what I want to see from the assessment is I want to see you implement what we learn throughout this week, right? How to define an interface trait, how to implement that interface, and also use the Starknet core modules, such as the contract address, get caller address, and I mean for the curious minds, right? You can also sort of like implement contract cross-contract interaction to sort of like solidify your understanding of how contract interact with each other. So yeah, this is like all of it that has to do with the assignment.
Hello, sir. Hello, sir. Are
Okay.
you pushing today's code to GitHub?
Yes, I would definitely do that.
All right. Okay.
There's someone that raised his hand. Is it Wisdom? Did I answer your
Yeah,
question?
it's me again, sir. Yeah, you answered it, but I have another one.
Okay, yeah. Go on.
Are we still going to deploy it to the maybe testnet?
So the deployment, right? I can deploy it to the testnet here, but you guys will really not understand what I'm doing because we need to sort of like set up deployment accounts, deploy the accounts, then get tested get test token into the account and sort of like deploy it. So
No,
and I
my
don't know,
question
I do
is
not want to like
my question
go on.
is, are we like supposed to kind of research on how we are supposed to sorry. My question is, are we supposed to kind of deploy it or like find a way to deploy it on our own? Is that the assignment? Or should we just push to GitHub and leave it like that?
Yeah, so the assignment is to am I right? Section of how to deploy contract, and then you can deploy it. And if you have any question, you can always ask in the group. I will try as much as possible to respond to that question. I mean, this is like a challenge to you guys. This sort of like info to you guys how to there would definitely be a section where deploy your contract.
So we can't hear you. Your voice is breaking, sir.
Oh, okay, yeah, I can see that my network is acting up from here. Yes. So like I said, right, the assignment is you basically building a contract and pushing it to GitHub. So the assignment is on the slide, right? And I'm very sure you guys all have the slide. So, but I'm going to share the slide. Okay. Okay, this is the link to the slide, so you can have it there. Wisdom, I saw you raise your hand a while ago. Do you have any question you want to ask?
Actually, the question I wanted to ask, this guy have already asked it already. Just to clarify, to do a recap about the assignments which he just did.
Oh, okay, awesome. So in the absence of any question, I'm going to deploy this. I'm going to sort of like push this code that we did on GitHub and share the repo link tomorrow morning, right? And I look forward to seeing where you guys will build with the bookstore. I remember to know that we'll look at the commits, right? The time the commit and when, like the date, like when the commit, everything is being committed and all of that. So yeah, Wisdom, do you have a question? Say your hand raised now.
So is it the one that we did today are going to be committing, like we'll be deploying to the GitHub that will be getting the link or everything that we've been doing so far?
I shared the link to the previous one that I deployed, like link to the previous GitHub of the code that we worked on, the one we worked on Monday and the one we worked on Wednesday.
Okay, no problem. Let me look for it then.
Yes, it should be in your side. Yeah. Okay. Onyeka. Yeah, I think Onyeka is having a network problem.
Please, I didn't get the link to the project you said you submitted on GitHub.
Okay. Let me find the links and share again.
Thank you.
Where is this? Okay. These are the links to the contract. Oh. Yeah. I just dropped the links to the contract in the in-call message, so you can pick it up from there. Okay. So in the absence of any question, I look forward to seeing how you progress through this bootcamp, and I look forward to reviewing your code assessment. Yeah. Thank you. See you guys on the other side. Bye, everyone.
Hello, guys. Good evening. Sorry, are we free to log out now? I can see that the call is still recorded.
And they have sometimes sort of flashes of, it getting better, and then you get to a weekend like this and it doesn't seem to be looking so good for them. I think he's going to be looking at the future with the team, and keeping the morale in the team up is going to be a big part of it for him.
Obviously, a lot of noise about what's going to happen. Kind of talk to about that subject when they predict his future. I can't until after the weekend. I think that's when the decision